Yeah, I agree with that actually. Go on. But I
don't know even know what's going on. I mean,
So I washed it. And then I took it on the wash and I was like, oh, my mum just fell out of the pocket. So he took them and then not took them out.
NSA ID.
I think it'll be on repair.
Did you think side hobbies are okay? Yeah, maybe they're not.
Still,
Trying to follow a tablet and
have you tried all of
They tried to swallow it. Watch.
it'll just dissolve and
can't swallow it, it's supposed to dissolve when you put it in your life.
If you told you, my nose pierces. She can't swallow it and she can't get it right to the back.
She's got one leg, that's disgusting.
Well, good afternoon, everyone. Thank you for coming. So my name is Dr. Oluyemi Kaide. Everybody calls me Isia. I'll be in charge of the afternoon section. The programs have four speakers, and then we'll move on to the panel discussion activities, then talk. But could you kindly go to the back of this scan back with the kindly scan it and fill in. I will have an idea of how many will be following us to the talk. And we'll be starting with our next speaker, Dr. Craig Macbeth. He's an early career researcher at TISA University, currently engaged in the field of bioelectronics, chemistry, and materials engineering. His current RSC-funded research includes developing novel bioelectronic research and improve accessibility to sustainable laboratory practices. Join me as we welcome Dr. Craig Macbeth. Thank you.
Thank you very much for the introduction. Hello, everyone. I am Dr. Craig Macbeth. I'm one of the lecturers here at Teesside University. Funnily enough, I have a background in biomedical sciences. I went on to do a PhD in electrochemistry. Then I did a whole bunch of different postdocs, dotting around cancer metabolism and engineering. And here I am now trying to find a way to make plastic useful again, at least from a laboratory perspective. Quite interesting when we look at sustainable practices in academia, because a lot of what you see is usually very technical, very complex, and a lot of it's design and construction, and a lot of the products that are created are only done so through very expensive machinery or equipment. While that's fantastic for creating novelty and for providing the world with, as people keep saying, cutting edge technology, it's not greatly adaptable from industry to industry and between different institutions. So what I've tried to do right now is develop a project that looks at recycling one of the most commonly disposed of plastics in a lot of biology, biochemistry, and chemistry labs, which will be polypropylene. Also looked at one of the other growing issues that we have, which is obsolescence when it comes to waste, electrical and electronic waste. Each of us right now, strong chance that a lot of us are holding in our hands a small rectangle filled with some fantastic developments, some really impressive computer chips that will be no doubt outdated in about 2 weeks, if they are not already out of date by about 6 years. So what we're trying to do right now is take these two problems with electrical, plastic waste, combine them together and see whether or not only can we try and minimize this waste, but can we actually produce a product or products that ultimately are novel and have different applications for what to use them for. So, predominantly see plastic, skipping ahead. There we go. A bit of a delay with the click. You're probably very used to seeing images like this, where we see plastic being thrown into landfills, plastic being thrown into the ocean, and everything like that becoming a problem as time goes on. And while domestic waste like this is a huge problem, it doesn't really compare to what we as scientists do per person. An actual standard benchtop scientist will produce roughly 0.8 tons of plastic waste per year. That is per benchtop scientist. This is from a study taken in 2015. Considering how we have developed year on year and how glass and a lot of other reusable materials have been slowly diminishing over time, that amount of plastic is ever increasing. Something that we ideally need to rectify sooner rather than later. And a lot of these plastics are used literally once for a very simple task, be it to transfer water from one area to another, and then that plastic goes straight into medical waste and is never seen ever again. Off it goes to the medical waste companies and it's incinerated. Unfortunately, that produces these large amounts of waste that we ultimately can't really do a lot with. We need to ideally try and find better ways to reuse these plastics and try and save a lot of these materials just being incinerated and not being used. Some of the recycling can be done in labs. So for example, if we do just have water being pipetted from one thing to another, a lot of academic institutions have already started to implement changes to rewash or reclean or reuse these pipette tips. However, when it comes to biological contaminants or certain chemical contaminants, we start to kind of fall into territories of, is that safe? Is that sketchy? Should I be really trying to recycle a pipette tip that's had E. coli in it? And it's true, it's a big problem. Hence, a lot of times, most of these waste that we're kind of looking at that has been generated is also generated by health industry. So the NHS is one of the biggest people who will also consume an awful lot of plastic waste. So the plastic that I've identified is very commonly used in most pipette tips. They're used in a lot of lids. They're used in HPLC vials. We can get various materials made out of them. Is polypropylene. Now, polypropylene is a fantastic plastic for several reasons. It has impressive chemical resistance, really good in strong acids and strong bases, can be good with a wide variety of solvents, not necessarily hydrocarbons, but a wide variety of different solvents. It has great fatigue resistance. You can reuse it again and again and again without almost no loss in structure and form. We also have a reasonable amount of temperature resistance, up to about 160 Celsius as a melting point, meaning that we can, to a certain extent, expose it to autoclavable temperatures. It's the reason why a lot of pipettes, if you buy them in not already pre-packaged, will be put through an autoclave and sterilized that way. So they are very resistant. They are, like I said, one of the most used plastics in the lab, and sadly enough, one of the hardest to recycle effectively because of some of these properties. So bear with that information in your minds for just a second, because I'm going to now caveat to a slightly different area, and that is waste electrical and electronic waste. Now, there's a good chance that a lot of us here, like I said before, have thrown away certain electrical goods, be it through actual recycling means or through non-recyclable means, because we just assume they can't be recycled. You think about what you produce, that's fine. It's not a huge amount. But when you go into academic institutions or certain office places, they usually have a new turnover of electronics every couple of months, every couple of years. I'm sure a fair amount of us have been into a lab where there's a piece of equipment that's initially started off light, been slightly off-white, and has slowly developed this sort of yellowy brown color over time because it's been there for years and years. And then eventually, when you do replace it, straight to the landfill does that machine go. Now, the downside with a lot of that is, unfortunately, we in the UK produce one of the highest amounts of electronic waste, and it's ever growing as time goes on. The average domestic individual, this is just us personally, roughly produces about 9 kilograms of that e-waste every single year. Roughly about 30% of that is currently recycled, which is great, but not all of it is repurposed effectively. One of the main materials that we lose in a lot of this recycling process is a variety of semi-precious metals like copper, nickel, aluminium, and brass. So like our phones right now, we fill a large amount of copper, silver, and gold. And that's the part that we care about right there. These precious metals, these golds, these platinums, these silvers, palladiums, iridiums, all of it is dominantly held within these high value electronics that we all have hold of. And it's even prevalent and present in a lot of lab-based machinery as well. Cool. So we've outlined two big problems there, and especially when we're talking about electrical waste. That's great to know, but ultimately, why do we care about that? Why can't we just keep digging? What's the problem with just keep mining this stuff? Well, we can if we want, but the reality is ultimately conventional mining, roughly you get about 5 grams of gold and 5.25 kilograms of copper per ton of ore, which is not a lot of material considering how much mining you have to do, how big the machinery is, how many people you have to employ, all the regulations and requirements to acquire this material, and how much processing has to be done to extract it to its pure form. Whereas if we do what's called urban mining, which is the recycling of these waste electrical goods, we can harvest roughly 1.5 kilograms of gold and 210 kilograms of copper from waste electrical, which if you do a quick bit of math, you will see that that is substantially more than the tonnage that we see extracted from quarries. Not just good for actually improving our yield of our product that we can get, it is better for reducing a lot of these processing costs. So you don't have these large factories that look to break apart the ore, purify the materials, and ultimately we reduce the amount of excavating equipment. We don't need to take up quarry space. We don't need to transport it across the country. It can all be done in a factory where it can be very quickly isolated and extracted back from its previous form. Also more in line with carbon negative and carbon neutral sort of goals, the idea of repurposing and reproducing this material rather than just leaving these big diesel requiring vehicles to harvest and effectively collect. So those are my two problems. How are we now going to solve these two problems? Well, a bit of a two-pronged approach. Apologies for this image and its quality. I'll try and explain it. I thought it would be bigger. We have our polypropylene waste already, and I've identified roughly some of the parameters that we need to retain for them to be considered useful for further use. Now, thankfully, polypropylene and its structure allows itself to retain all these qualities once it is melted and then restructured. So what we have been working on is whether or not we can take these polypropylene materials, grind them up into a small enough particulate, and then re-extrude them through a machine that allows us to create a filament that is used in a 3D printer. Through that and a combination of some very smart CAD design, we have been able to create various structures and vats that are resistant to chemicals, allowing us to place this waste electrical goods within these vats with these chemicals called deep eutectic solvents. We are able to, in theory, extract these various metals and various plastic polymers to create novel materials. We can create a variety of different things, hopefully metal oxides, pure metals, ideally, that would be the optimum goal. We can create pure metals and potentially metallopolymers, which is great because then that lets us go on to make other really quite novel materials, such as conductive filaments. We can make various nanomaterials that have a combination between metallic and plastic-based structures, or entirely novel structural materials that might be used in, say, building supplies and other potential applications. The deep eutectic solvents that we've identified for this project, you may be new to this, hearing this term, are designed to be recyclable themselves. So deep eutectic solvents have been pushed forward as a new, more greener way to do extractions. Usually a lot of the chemicals that we need to use to extract these metals and break apart these components that we have in waste are quite aggressive, they're not environmentally friendly, and they aren't really reusable. The DES that we have identified are a little bit friendlier, they are nicer and diluted enough, they can in theory be put through standard waste processes. They also can be reutilized again and again and again till eventually we don't see them extracting, at which point that's when they are disposed of and we start again. The idea with these DES is to manage to create the opportunity to extract these metals and metal polymers to create aforementioned materials. So, why is that interesting? Well, to me, as a bioelectrochemical engineer. I love making sensors. I like making electronics. I love making things that sound a bit weird and wacky, trying to find some form of application for it. One of the most common things that we would obviously use this for would be the creation of novel sensors, as well as creating little structures that can be utilized in a variety of other different specialisms, such as cell cultures, as identified over here. So one of the other things that this project looks at doing is not only recycling these materials into a particular format, but also then immediately repurposing them for application for research-based tools. For me, in this instance, it would be for some form of electroporation or AC field stimulation technology that can be used for cancer metabolism studies. So let's start off with this project. I'm going to go through this a little bit step by step. Apologies if some of this is a bit clandestine, but you're literally seeing the project in real time. So initially, when we were trying to find what sort of materials we should look into when it comes to foul polypropylene, we picked some of the classic ones that we see in a biological lab or a biochemistry lab. First being, we have bacterial contamination in our polypropylene. If so, how do we treat it? Do we have blood or some sort of bodily waste contamination in our polypropylene, which we need to then deal with? Again, finding an application for dominantly healthcare industries in this instance. Or do we also focus on chemical contamination of polypropylenes? Now, the danger, unfortunately, as I mentioned before, with chemical-based contamination is not all chemical contaminants can be cleaned and sterilized in a way that is similar to what we would use for bacterial or biological contamination. So for the meantime, we're shelving that. However, it is something that we hope to do once we have optimized a lot of the other processes recycling this polypropylene. So to start off, we took some very simple pipette tips that had been used in a variety of different bacterial cultures. We have one that's been used in E. coli, Pseudomonas, and one that's a variant of our very dangerous, very scary MRSA. Found through the combinations of enzymatic solutions, a little bit of agitation through sonication, and then a slight bit of autoclaving, we do manage to completely clean our non-contaminated our contaminated tips to make a non-contaminated material. Now, you're probably thinking at this particular point, why not just reuse the tips? Why not just reuse the plastic immediately for its application? A couple of reasons. One, unfortunately, the process does slightly malform some of the plastic a little bit. So in this instance, it's trying to find the best solution after we've managed to sterilize them. One of the things we weren't trying to avoid was if, for example, we just sent them through an autoclave, would we still have remnants of bacteria? Would we still have remnants of blood within our sample? So by doing this process, we clean them out as much as we can so that when we actually get to the shredder and the filament extruder, we don't manage to foul the machines with our contaminants. We also did similar tests with blood and found that through the use of that process, that we were able to get relatively clean tips. So if we look here in the FTIR spectra of combination of sterile pipette tips, blood, our Turgozyme cleaning detergent, and finally our two different methods that we used for trying to clean out the tips, because initially we started with a rocker, just on a slight little undulation. But unfortunately, we found out that using that method wasn't fantastic for clearing the tips. So the sonicator was the best method that we use going forward. We find if we look at the profiles from our negative samples and our sonicated tips, pretty much exactly the same profile exists. We don't get any blood contaminants being found, nor do we see any bacterial contaminants being found either. So we moved on a little bit and we developed an in-house shredder. This is a machine that we devised in-house. Initially, we're going to build this entirely from scratch. But one of the things, again, as I keep saying about this project, we want it to be adapted at other institutions. We also want to keep the costs down for this entire project, simply because if I tell another university, oh, you can do all this and recycle all this plastic, but it'll cost you £60,000. They're not going to be like, oh, yeah, money. No, so we're trying to keep this as cheap and as affordable and as approachable as possible for everybody around. So all of these things, while it looks like an absolute hodgepodge of different technology, most of this was purchased from companies that sold them for under about £1,200 for all of this apparatus. There's been a few little bits that we did in-house, had a little bit of wiring done by our in-house electrician, and that's pretty much it. And our engineers built us this table, great little table. Anyway, but that was able to provide us with a very fine and consistent particulate. We were getting some really good regrinds from the polypropylene that we were able to produce. The only downside with this, though, was unfortunately we were getting a very inconsistent filament being produced from our filament extruder. I don't know if anyone here is too familiar with 3D printing, but for those who aren't, most 3D printers work on 1 or 2 gauges of filaments. 1.75, and I believe the other is 2.85, correct me if I'm wrong. And those machines work perfectly fine when you give them exactly that. If you go slightly outside of those parameters, it doesn't like it and it doesn't print well, and it's very hard to create anything that you want to print if you're slightly out of calibration. So given that we are trying to produce a 1.75 millimeter filament and only getting 0.83 millimeters, we are having a bit of issue with consistency. So that was our very first problem with this project. And it led us to learn a little bit more about polypropylene. Polypropylene is a very interesting plastic, especially when you don't have an awareness of it, and all of a sudden you're like, why is it doing that? Polypropylene is a semi-crystalline structure initially when you heat it at a different temperature. So if you heat it cool, it produces this very cloudy and almost not opaque material. Whereas if you print it at a high enough temperature, it's almost transparent, which in a way helps us to work out roughly what sort of settings we need to use to create the filament that we want. Atomicity is also a huge issue with this material. And because of the way that we extrude it through the filament, we are getting variations in what sort of structures are present. We're not getting a heterogeneous presentation in our material. We are starting to get these really odd structures. That's why in that previous image, we start to get this coiling because we're getting different hardenings at different time points. So trying to optimize this has also been quite a problem for us as well. But as with anything, we learn, we develop, we optimize, we overcome. And eventually we start to look at what industry are doing to produce these filaments, seeing how are they able to do this and why can't we? And that's fantastic. They have these big machines that cost £100,000 or so. And that's great if you've got £100,000 to spare. We didn't. They even have, if anyone's ever looked online trying to create their own filaments, domestic level filament producers. Again, aimed at the average hobbyist who just wants to make their own filament. Again, that's great. Still cost about £8,000 or so. They aren't the most approachable nor the most affordable, even for a hobbyist. So we have this machine called the Mark MKS3. It is half designed by ourselves, hence the white is stuff that we have 3D printed ourselves to make this device. And it is able to recycle an awful lot of different plastics from PLA, ABS, TPU. So there is not a huge amount of data on polypropylene. So this has been a really fun time trying to optimize this and get this to work. So €771 is the cost of this machine. Again, it's all about trying to make this process adaptable between these different institutions. So we're trying to keep the costs down, try and keep it approachable. The same, accessible, affordable, implementable, and ideally, eventually when we get to it, automated. This is going to be one of the latest steps that we've done once we get a few more things optimized to try and create a system that ultimately can detect when a filament is being extruded at the correct temperatures. And if there's any shift or change in the filament diameter or its filament properties, we can get the AI to start to modify it and change the parameters on this machine to make for a more consistent extrusion. Now, we realized that one of the problems with our shredder was it wasn't producing a consistent sized particulates. Particulates did vary quite a bit. And because we're also trying to recycle the filament that we initially fail on, we're also getting inconsistencies in those regrinds as well. Which led us to have to then start using a blender to make sure that the particulate was much smaller, much more consistent, and ultimately produce a much more consistent diameter of our filament and the filament diameter, which thankfully, because a lot of these printers that are out nowadays have very intuitive slicers, thing that allows us to tell the machine how to print certain plastics, we can start to modify these settings and print materials that will be beneficial and actually structurally sound when we come to print them. We have got a few bits to test. This is roughly where we're at with this project so far. We're going to be testing the tensile strength, a little bit of the flow index, the elongation, and ultimately the impact resistance of this material. We're about to literally step into testing for DES resistance and if there's any interactions between our plastic that we've extruded and some of the deep eutectic solvents that we plan to use for extracting our waste. And once we get through that, we're going to start combining things together and see if the material is structurally sound enough that we can actually extract the materials from our electronic waste. So far, we have found that we are able to print our polypropylene. We are able to create quite a nice little structure. This is only a small one, it's like this big, it's really cute. But we will be making quite big ones that we can fit whole motherboards in or daughter boards in and extract metals that way. The only thing that we're currently trying to overcome at the minute is as mentioned before, with polypropylene, we do see some slight warping and movement of the plastic, especially when we're 3D printing. So we're seeing a slight bit of warp on the bed, but the material in itself is staying completely watertight as so far. So we're very hopeful this is all going to work out beautifully in the coming months. With that said, that's pretty much the end of my presentation right now. Just want to take a hot moment and thank everybody who's helped with the project, from the lovely technicians over in Byres who have constantly put up with my pestering from equipment. We have my wonderful RA who has pretty much generated all of the data for this particular project. She's just hiding back there trying to be conspicuous. If anyone's looking for a new RA, please consider her. And special thanks to anyone else and some of the undergrads who have worked on this project. And of course, the RSC for the money. Thanks for the money, guys. Anyway, thank you very much. Anything else?
I could probably come in the lab and just ask you, but have you know your issues with the inconsistency of the printing? You find that stage of trying to use a warm chamber yet, are you?
Yeah, it has got a warm chamber.
Oh, has it?
Yeah, the inconsistencies hasn't really been with the print. The print, thankfully, has not so far been a problem. It's the filament diameter, and it's because once it is extruded through the nozzle, it's immediately hit by a fan on one side, and then the other side.
Because certainly with the bamboo ones, a lot of when the print of PP, but you know, then the fan documents that instantly rolling in the fan.
Yeah, the actual printing inside the printer itself is pretty fine. It's just trying to get the filament ready to, trying to get the filament into a state where it can be printed. That's unfortunately our issue.
And also, I guess temperature is not really an issue for your printing. Because it's mainly chemical feed.
Oh, it's thankfully polypropylene will melt and flow quite reasonably well within a 3D printer.
Actual what's used, because one thing from some original research when they started using polypropylene for making tip boxes, they actually found that it didn't have the same tensile heat strength as normal polypropylene. So
we haven't got that far yet. And thankfully, because of the way that deep eutectic solvents work, we don't really have to heat this up. It all works at room temperature, which is quite nice considering extraction at temperature is a scary thing to do with acids. But no, the biggest concern that we're worried about so far is just trying to get consistent diameter, make sure that it stays well within our confines of what we're willing to accept for printing consistency. But also the polypropylene itself, when we're printing it, polypropylene, for anyone that doesn't know this, polypropylene doesn't like to stick to anything. It hates it. So if you're trying to print polypropylene onto bed of a 3D printer, it just immediately goes away. It like strings off. So we found that polypropylene loves to stick to polypropylene. So we print polypropylene and then try and separate the two, which is a fun challenge in its own sometimes. But yeah.
You have one question.
There is a question. Hi.
Yeah, just apologies, I'm not a chemist.
Right. Neither am I, really.
Is there a difference between coloured polypropylene when you are trying to break it down and reuse it? Have to extract any of those impurities from the coloured ones?
We've not got round to investigating that yet. There will be a difference because they'll have different additives that give them the colour. We've not found out whether or not they have any interaction with one another, whether or not they cause delamination or an inconsistency in filaments. Right now, we're trying to keep everything as controlled as we possibly can so we can at least establish fundamentals. Then we're going to hopefully eventually just branch out a little parts, and one of the biggest ones will be using colored polypropylene. Because you'll probably see it from time to time, every now and again. I believe places like Fisher will be like, oh, we'll sell you blue tips for a cheap price. So people will just buy in a load of blue tips made of polypropylene. So it'd be interesting to see what happens. The ideal dream, is to have a different machine for different colors. That way we retain that consistency and we don't get contamination between batches. Who knows? anyone wants to give me some more money so I can try that out, go for it.
I have a question and probably maybe a suggestion. So when you are extruding the plastic, use fan to cool.
Slightly, yeah, we have a small amount of cooling done for fan. Reason for that is because we have to heat it to a high enough temperature to obviously make it molten and have it come out of the extruder tip. The problem is then what we do is we refeed it back through a Bowden tube where it is then wound onto a wheel. If we don't have a certain amount of fan speed, it gets too molten and it just hits the bench and it sticks to the bench. But if we go too fast, it crystallizes almost entirely on one side and we get that really coiled looking material. So it's kind of like finding a sweet spot with it.
Have you tried cooling through water, then go to the stream?
We have seen a variety of things. One of the things that we would love to do is to use what's called like a cliche dye. And it's what they use in big industries, like you just saw in that lovely picture of that £100,000 machine. So what they'll do is from that is they'll pull the material out, put it through one of these dyes, and it'll almost consistently make the diameter exactly what they want it to be. But it costs a lot of money, and our machine is only £200. So it's like I say, it's trying to also make it approachable so that people who want to adapt this project can just buy the stuff, follow our protocol, and do it. They don't have to refabricate anything else or try and do a little bit of optimization themselves. They can just adapt our protocol.
Great to hear. It's like, just one, what is the shredding mechanism that you use?
Sorry?
What is the shredding mechanism that you use?
Shredding mechanism.
I think you built yours.
Yeah, we did, but thankfully, you can buy it. Well, you can buy part of it. So the shredder in this instance is this very large metal contraption. You can buy the whole thing from, I can't remember the name of the company. I can send you it if I can remember it. But it's these very large teeth, and for the most part, it grinds the particulates, the plastics down into particulates roughly around about 0.5 to 0.9 centimeters in rough length. But we have been refeeding it through to try and increase the consistency between materials. But the best way we found to get consistent for the most part has been putting it into a blender. And the blender is thankfully making it quite homogeneous in that instance.
Is there any difference between the normal virgin polypropylene 3D printing temperature and this recycled temperature? Is there a difference that you observe during printing?
Not yet touched on virgin polypropylene. It is something that's in the pipeline to do. Funnily enough, not many places sell it for a reasonable price. That's the first thing, reasonable price. Polypropylene is hilariously quite expensive for 3D printing applications. A lot of 3D printing materials, so for anyone who doesn't know, you can roughly get a kilogram of plastic for about 18-ish pounds, give or take 25-ish if you buy the good stuff. But if you want to buy polypropylene, even if you buy the cheap stuff, the cheapest you'll get it for the same quantity, if not slightly less, is about 40 to 50 pounds. So it does become quite expensive to slightly experiment with. We are going to be looking at virginal or a commercial grade polypropylene that is using a 3D printer to compare it to our polypropylene that we are also going to be 3D printing as well, just to see how the two can compare in that comparison.
Excellent. To see the mechanical properties, how it is.
Yeah, because it's going to be a crucial thing because ours is still quite clouded in the manner, whereas the one that you buy commercially is really transparent. They have clearly got a lot of money in one of those £100,000 machines to produce that.
Your tip. I mean, can you not use a water trough to cool?
Believe it or not, it's one of those ones where when you view to use a water trough, you potentially could cool it down consistently. The problem is when it's extruded, it immediately, almost as soon as it comes out, if it's too hot, it'll just, like I say, deck and it'll become this very mushy. Yeah, this very mushy bit of plastic. But if we're 5 degrees or 10 degrees below that temperature, it almost immediately crystallizes. It is rapid. It's one of the biggest problems with polypropylene.
Run in the water trough, like, I mean, how we do the cutting, like cutting process.
We can give it a go.
I'm just saying.
All right, it's all right. It's something that, like I say,
Because sorry to cut. I think there's one in Stevenson's building.
Yes, that's
Similar.
it's horizontal actually.
Yes, I think maybe you need to.
You need to try.
go and have a look.
Yes, yes.
I will have a look.
We used to do crystal cutting, the soluble crystal cutting, and long ago with a thread going through the water and
Yes.
then.
The problem with polypropylene is actually I think there's one major supplier of polypropylene 3D printing. They've set an entire company around with producing that. That's how difficult it is to produce really polypropylene. their type is.
That's why a lot of times in our design, when we're going to actually create these bats, one of the things that you consider when you're 3D printing things is obviously the number of walls and how many layers you have between your top and your bottom layer. We're actually considering using quite a large number of walls and a large number of top and bottom, mainly just trying to keep it watertight. So in our eyes, as long as we can get it watertight, resistant to DES, and it doesn't leak anywhere, we're going to call that a win, even if the quality is not completely optimal.
Thank you very much. If you need during the panel section. So next, we're going to be having Mr. Gideon Elizor. Mr. Gideon Elizor is a research assistant to Dr. Achadu. He's currently supporting research into nano generators fabrication for harvesting extremely low frequency magnetic field for electrical appliances. Kindly welcome Mr. Gideon Elizor.
Lucilla Gideon, Dr. Soon. Research assistant with Dr. Achadu at his lab, and one of our projects we're going to do sustainability was how to harvest the nano generators that we're basically Dr. Achadu said something earlier that chemical experiment is just simple like this, but those simple things requires like stirring. Use magnetic stirrer, and might be like 1 to 48 hours, sometimes longer. Drying, similar time. Heating, everything combined together gives us that. This is the reality that scientific research, as much as they are very important, are also very, very resource intensive, especially in terms of energy. So everyone has different concept of how to make labs sustainable. So you have the net zero itself, which is, according to Dr. Ellis, says net zero in terms of infrastructural design, how to incorporate that into making it the whole building itself and everything in it sustainable, conform to sustainability. Then you have day-to-day actions in the lab. Okay, I use a fume hood, shut the side, bring the search down. I turn off the equipment if I'm going out. I do lots of different things to just to conserve energy and other resources. However, in terms of energy, these are sometimes impractical. So experiment needs to go on very, very long. There's no way you can say, okay, you are trying to like reduce the time, but sometimes very long. That's just it. But one reality is this: for a HPLC machine, you have just one. It takes about 690 kilowatts annually. Some lab complex like this one, and you have like in Tisa University, you have BIOS, you have Stevenson, you have quite a lot of different ones. Sometimes you have like a collection of these machines lab. So that's just for one. Now extrapolates to the whole of the UK, and this is the same trend globally. Same with the fume hood. Our own strategy is just to go away from okay, we know the day-to-day actions, we implement that in the lab, we try to make our own practices sustainable. However, we are looking at, in terms of appliances, lab equipment especially, applies the energy intensity of the thing. This we cannot do without electricity. And one very good property of electricity is that it produces magnetic field once it's in operation. And these appliances also, and we're looking at, okay, can these magnetic fields be harvested? Yes. How? While we are trying to create nano generators to go further with this, we still need to quantify basically how much of this magnetic field is available per equipment in the lab. That's the simple experiment we just say quantification that we did. Like, okay, most labs have magnetic stirrers, they have they have pumps, they have ovens. So, but what is being generated in terms of magnetic field in distance? Few of the research so far carried out are for appliances generally, and they are looking at the health effect of ambient and magnetic noise and other things. We're not looking at the health aspect. We're looking at, can this be recycled? Can it be harvested? Can something good come out of this? So that we can like, okay, what's the estimated power output that can be gotten from, can be harvested from this and recycled back and used to like do something useful. This is basically what we do. We understand that, okay, each equipment based on a magnetic field, we can call them radiation. From the immediate vicinity of the equipment itself, once it's in operation or on standby, the field increases according to distance. So we just use a Gauss meter, which is a bit more professional, and then this is something that's popular with Ghostbusters and people who are looking for paranormal activities. Not as accurate, but just to like compare their values, right? So what we just do is take this, use distance as in to say, okay, how the magnetic field compares with distance, get a note of it, and so in fabricating our own nano generators, what will be the optimal location and how to place them to get viable energy from there. Basically, this is the steps we took, each as in at 0 distance, 1 centimeter, 2 and up until 15 cm. Just notice that, okay, once it's above 15 cm, you start getting the same background magnetic field that's available in the equipment. It's basically 6 inches. So we were able to measure the magnetic field generated by 17 equipment. Different modes have standby, you have operational, and only something is the slight variation on standby. They call the name operational equipment, or a few others are properly there's a very large variation. So we found out that, okay, in all this, you have 4% of it producing above 100 microtesla, which is 1,000 milligauss, which is the unit of magnetic field. Funny enough, one of the equipment that does this, as in this, sorry, I jumped forward a bit. Among the measurements that we could say, this just gives you a brief lesson on what's the measurement taken for equipment on standby. So the sonicator still remains tops. It's on standby itself, gives you about 430 milligauss of magnetic field, followed by the magnetic stirrer. That's probably 2 centimeters, which is the baseline of what we used as a reference. Down that just gives you an idea of the difference the field generated by the equipment available measured. We can see that, okay, even something like the FTIR charger generates something that's appreciable, magnetic field that's appreciable. Computers also, and some of the other equipment that we have that uses chargers do the same thing. The top emitters basically is the sodicator. That's one of the sterile hot plates. Something that's observable is that we have different brands of sterile hot plates. Each produce different. They have like the second one, Amicus. You have the yellow line MSC Basic, and then there should be Struts UC 152 and 152. All generate different magnetic field while they are on standby. So that tells us that okay, the magnetic field generated is dependent on brand and let's say design per se. And keeping note that since there's that awareness of magnetic fields of protection against radiation per se, even if it's not ionizing, ELF measuring, that they use Faraday shields and some other kind of shielding materials to like make the equipment. So definitely you expect that there will be variations in field. In terms of when the equipment is on, this is our own observation. Once you power on equipment that is in use, the Edwards vacuum pump gave about 68 milligauss of magnetic field, going upwards up until the different sterile plates. Our delimitation is that this, for the magnetic sterile hot plates, it was above the measurement threshold of our own equipment. But that's 2000 milligauss. It's just, and that's when if you're like from 0 to like 3 centimeters from the top. If you measure from the side, it's actually by 1000 plus, but this is from the top. So once it's in operation, and basically it just tells you, okay, in the lab so far among all the top emitters, say that 6% gives probably from 10 to 50 milligauss of field, and then you have 5%, 1% giving 5 to 9. Then 4 ideally, it's just a fancy term for like just give the term visual, good visuals. Is a 50 to 200 milligauss generated by 43%. One good one there. Sorry. Yeah, sorry. Sorry. Let's touch it again. Touch it again. Okay. Thank you very much. Apologies for that. Yeah. So at the baseline we are looking at actually for something that is viable to be invested is from 5 microtesla, 50 milligauss. That's what we are looking at. Okay, can we see something? Can we identify equipment that on standby or in operation generate magnetic field that's range, something that's above 50 microtesla? Quite a few of them that are.
Drag the pencil on the screen to left like this. Drag it down, drag it down. Yes, perfect. Thank you.
And we just okay. Among the equipment measured, you still have the ones who are top emitters when on standby, and also top emitters when in operation. And I would say funny something is some of these states, once it's powered on, it's already on, even if it's not in operation. So it generates similar magnetic field, whether they are on standby or they are in operation. But for others, it's quite stable. Once it's on but not in operation, the magnetic field differs. One also notable something is there are some equipment that are pulsating, so they might generate very high magnetic field, but it's start varying, and then it changes also. So you when you start measuring, it gives you very different. However, it still tells you that at the time it's in operation, it can still generate viable magnetic field. That's it's what we hope to. And the take home from this is just basic. 63% of the lab equipment in operation have magnetic field that can be detected. At least they are detectable. While 13% had above 10 microtesla. While 5% generated more than 500, which this ideally is like the EMF of the Earth, for the Earth. We have quite a few research that was tried to like test that using the bulk meters and everything like that. So we are hopeful that we can tap on some of this and then try to like harvest something via something reasonable. It's not going to power your phones, definitely not, or computers, but it can power some small devices and sensors like that. And then going forward from it, it's just the ultrasonic bats, as already spoken, give the highest detectable magnetic field. So the ultrasonic bat get the highest on standby and also give appreciable pressure, while the hot place were like super. You could actually deduct from it that okay, deduce from it that okay, most of the equipment that have coils or have magnets included in it generate produce magnetic field. In terms of the vibrometers in operational mode, these are just like the list of what is available. You have the complex magnetic stirrers, complex mixers, blenders, ultrasonic bath, microwave ovens, orbital shakers, and it's similar in terms of the ones on standby. This is just a schematic setup of what we hope to achieve in the long run. We're able to develop our own generators. How we get to like tap from this to power devices that at least do not consume much. I will conclude basically as with the home, with the lab, we have enough equipment and appliances there that piling up on standby, it generates magnetic field, and this can be calculated. Just as technology improves and we're able to like make our own research a reality as in going forward with the nano generator. Time, technological advancement and other things will help us know how to optimize what we get, be able to maybe eventually power whole buildings. Who knows? Thanks for the answers. Already explained the team. So sorry, the teams from BIOS and then the other guys in Orion, Stevenson, you're not here. It's Zero here, and then NHC, who supportive of give us the time to be able to like take a few measurements. And thanks to my PI for present.
I just have one. I want to follow up on her question. I know the emission is small and it doesn't charge. But if you're trying to charge to channel it into a whole building, are you saying all the equipment in that building has to be on? What's the health implication of that?
Health-wise, different regulations for in terms of place, but it has to be above 1,000. That's the
Okay, for
threshold.
you to react to.
Yes, 1,000 microtesla, not 1,000 microtesla. However, have some, will I say, common sense. They kind of need to 4 microtesla. Your phone generates more than if you carry, most of us carry our phones about everywhere.
Yeah.
And there's definitely no way you go sit by the ultrasonic bats that you're touching it for like hours. You might be in the lab, but as long as this our measurement just showed at 6 inches, magnetic field of most of them are like 0 point something millivolts, which is
That was the 16 inches we are measuring.
Yes.
Oh,
so at 6 inches you had very just like background will not give you any, it's harmless. But in terms of harnessing it for making powering buildings, research will have to like as in time will tell. So you can only do for like LEDs and IoTs and other wearables, but less charging. But time is what makes everything easy, and time is what brings all possibilities into form. So that's what we expect. We are part of these projects, we're able to make something happen. Right.
Obviously, some equipment might have like Faraday shielding. So would you expect that if you could get the these budget creating into the, would you expect a much higher yield then? And would you also expect that to have a knock-on effect, as in then there won't be as much in the environment, so we can, and it has a knock-on effect of health and the effects of the environment and like that.
How much? The Faraday shield in itself, if you can't detect the magnetic field outside that, then it's not effective.
Yeah.
The essence of having that is to make sure that everything within is contained. So most of that's where most of the equipment you get, because of the shielding and the design of it, you just detect background. Nothing appreciable. So, but those that do not have those shields, those that you can readily detect. But even material-wise, you have some materials that are composites that are able to like reduce how the field propagates. So it's basic. Have I asked the question? Have I asked it?
Yeah, thank you.
More questions? Okay, so thank you very much for coming.
Thanks for having me.
Next, we're going to have in Mr. Kehinde Omoyeni. Kehinde Omoyeni is chair of Teesside University Energy Society. He's also an MSc student in the Electrical Power and Energy Systems at Teesside University. He is currently the R&D intern at the Faraday Training Center in Middlesbrough. Thank you very much for coming.
Good afternoon, everyone. My name is Kehinde Omoyeni. I'm an MSc student at the Teesside University, and currently studying electrical power and energy system. And I'm also privileged to be the chair of the Energy Society on campus. So basically, I'll just be sharing the leadership journey, what we do as the Energy Society, how the sustainability goal, how we achieve, how the students are also a part process of achieving the net zero goal. So we'll talk about what we do. We are a student-led society. What's our mission? Our mission is just to create a community where students can engage meaningfully. Part of what we do is students learn, students develop, innovate. So that's what we just do. That's our mission. So we see how to enhance the capabilities of students and create a platform for them. So what we do, we organize lectures. We, just like this event now, we were invited to collaborate. And so we have members of the society also here just to showcase some of the things they are doing. Is student leadership in sustainability. Now, I put it in three perspectives. We have the first one personal responsibility. So here we see the choices we make. I think the second, is it the second speaker today, Dr. Kumar, he made mention on the choices we make with respect to energy. And I think Dr. Utu also made mention of that with respect to harnessing the magnetic, how to harness that
Noise.
yes, yes, magnetic noise. So the choices, so personal responsibility, student leadership in sustainability involves this, how we live responsibly, the choices we make in energy, in waste, and also transport. And we also see campus and community leadership. So us is an example, the Energy Society, where we lead, we have projects, we have campaigns, and all this is just driving to what? Net zero. Then we have the last, which is collaboration. So here we see connect. We connect with networks, we connect with industries, just to what? Influence the SDG. The last trip we had sometime May this year, we went to a waste facility, the one at Bellingham, and there we saw firsthand, there's a difference between classroom, what you learn in the classroom, and then what you experience firsthand in the industry. So that drives it. There's a drive. So it takes you out of the atmosphere of the classroom, and then you see it practically. In fact, with that, you tend to have more ideas as to how things should be done. Why students' leadership matters. If I may ask us, who will lead the charge towards net zero? The second speaker made mention of policies, right? Well, I want to say that policies also have limitations. We'll also be looking at that. So who will lead the charge towards net zero? Actually, to be every one of us here gathered. So we have a collective responsibility, just like students also. So not just the policymakers, the government, and the likes. So we see governments. So governments, they do what? They set policies. But what do we see? The policies, the progress is slow. Industries, they bring up innovations, they sponsor technologies, but what happens? I think one of the speakers made mention of the recycling. When your phone gets spoiled, you take it back and then they give you another for a warranty period. And a question was asked, who now pays for that? And his response was that the consumers will still pay for it. And so which means that they do what? They prioritize on profits. Students are the key. When you look at the transition period, 2030 to 2050, most of students will become the major workforce. And so when we talk about the student leadership in sustainability, it's really, really matters. I'll just take a look at achievements so far. I came on board last year, October, and we have been able to achieve a lot. The society started sometime 2022, and we've had transitions, leadership transitions with lots of programs, lots of events. We take a look at just the picture to. So this was a trip to Glasgow, and fortunately I met Professor Kumar, who also was a speaker here, Professor Sentil. This was Wole Accounting event. And this was also a lecture we had on campus, where we invited the guest speaker, Professor Sentil. And here we also see field trips. Here we went to the Net Zero Research Village. Here we also see what's actually going on when it comes to the urbanization. Here we see this trip to Sembok, this trip to waste from energy from waste plants, and then this to SAVIC. You see here, you see Dr. Here we have. We have opportunities on campus where we welcome new students. And so this, and also 2 weeks from now, also we'll also be welcoming new students. And this one thing we're also doing, when the new students are coming in now, we're trying to create a platform where as they come on campus, they can also go on the field. So we have organized trips. As I speak with you now, we already have a trip booked this facility on the 17th, where students, as they come in, so we're not just leadership for ourselves, but leadership driving sustainability on campus. Research contributions. Now we have some of our members not just visiting, not just hosting lectures. We also see some of our members who are contributing to solutions. My internship period, I was able to work on this, and I've extracted a paper submitted. I'm hoping to get a feedback for the conference coming up in November. That's the Net Zero, Powering Net Zero Conference. And then we have some of us here, which I would like to spotlight, because that is the goal of the Energy Society. So we have, what's the name? Sorry, we have Adewale here with us. I don't know if you could just use 30 seconds or a minute to just talk about this.
My name is Adewale Ogabi. I'm a software developer, and I'm also instrumentation and control engineer from Teesside University. I've graduated. I'm working on a smart energy optimization, whereby I use Streamlit to program a software that determine the solar energy consumption. So it determines what the energy that you can save for a period of days, so that you can use it to determine how you use your solar panel and your solar battery. So that's what I'm doing. Thank you
very much. We also have another person with us, Tochukwu, is also working on this. If you just...
Hello everyone, good afternoon. My name is Tochukwu Baru, recent MSc graduate of energy. I investigated parametric effects within pyrolysis for turquoise hydrogen production, and that's decomposing hydrogen to separate hydrogen and solid carbon, which could be used for tires and other production. And I also designed getting more hydrogen from the solid carbon by undergoing gasification, water gas heat, and separation processes. And one of the things I noticed that it was temperature that has the highest effect on it, and pressure also had effect. But I noticed that at 1 bar, which was my optimal, I was getting good hydrogen yield of around 95%. At 1000 was also my optimal temperature, because I was getting around 85 to 95% hydrogen. I also noticed from 1000 to 12, I was having a plateau, which was almost relevant 96, 92, just a steady difference. And I also investigated the airflow rates, and I noticed that when I used 100 kilogram per hour of methane, and I also noticed that above that 100 kilogram, and my water input was 200 kilogram per hour, I noticed that above 100 kilogram of air input, that was my optimal. But above that, I was having full combustion, and that was consuming more of my carbon and hydrogen. By old design, which I will still have to work on the energy analysis to strategize more heat exchanger positioning and work on it more. I could get it. But so far, with the design process, I was able to get pressure of 1000, pressure of 1 bar which I could also look at 0.5 by my research at temperature of 1000. Thank you.
Next, we give a big hand to this project.
So here we see the opportunities. We already know the opportunities we provide for students. I also want to say that in poster session 2, you will also find some of the members of the Energy Society. You find their posters. The challenges we face as students: limited resources and funding. Leadership, we face that. We want to go for trips, no funding, resources limited, and then balancing academics with leadership roles. We find a lot of students running away from leadership responsibility because they are unable to balance their academics with leadership. And then we also see the need for stronger mentorship and support system. When I came on board, I found it difficult. Why? Because there were no mentors, there were no advisors. The system where I came from is quite different from the system here. Here, it tends to be more systemic. So if you don't plan ahead, you'll find out that you're not achieving anything, right? So everyone's role in student leadership, we have technicians, this is what they do. This is what we expect from technicians. They support us with practical knowledge. Lecturers, they provide mentorship. Researchers, they inspire innovation. Experts, they offer real-world challenges and solutions. And then we as students, we drive action with creativity. And together, we will empower the student leaders. So this is the core. Leadership is not just about the position. Responsibility. So you are occupying that position to work, to be responsible. And then I will also enjoy students here, join societies, start projects, start leading now. Then institutions and industries, just like the Net Zero facility and lecturers around, let's see how we can provide mentorship. Let's see how we can provide resources. Here in the UK, information is key. So if you don't have information, you tend to be limited. And then together, we'll shape a sustainable future. And so I appreciate every one of us here for supporting the drive towards sustainability. Together, we form a powerful coalition for sustainability. I also appreciate Dr. Joe for giving us the platform to be here. Thank you very much.
I just have in the aspect of funding. I just want what happens after the student graduates? Are the students team members?
I've been presented with that an issue. But what we try to do now is create a platform with continuity. I'll give an example. I'll be graduating January. As it stands now, I've been able to, with my team, I've been able to schedule the activities for the academic year. So even when I'm not there, still continue.
What I was saying, because if student graduates, they get into bigger position,
yes,
and their team members, they could help you with funding the organizations and can be a continuous thing for future.
Yes.
Okay. Thank you very much for coming. So our next speaker is Sam Kingston from Primans Group. Sam, yes, thank you for coming. So Sam Kingston. 19.
Yes.
Oh, sorry. Okay, that's what you were saying. You said 19.
Okay.
He's a TISA University chemistry graduate and a laboratory process and product technician at Primans. Also as a cable and materials manufacturer for energy companies. Thank you for coming.
I'll break soon. Yeah, I'll start with the introduction. I graduated from Teesside University in 2024, May. I went on to help Ojudomo at the beginnings of the magnetic harvesting project. After that, I started at Kingspan as a graduate chemical engineer and ultimately decided the place wasn't for me, but regardless, learned quite a bit from the position and then went on to be a laboratory tech at Prysmian. Prysmian is a cable manufacturer, so there's a lot of basis in energy companies and connections to them. It's why a lot of this is actually of great interest to Prysmian at the moment. I want to preface everything I say here with this is a small snapshot of industry, not a broad sweeping version of it. The importance of sustainability though, does dates mean anything to anyone? No. Those dates are Earth Overshoot Day, when we started using more of the resources than what the Earth could regenerate in a year. This year, as seen, it fell on July 24th. One of the benefits of COVID, surprisingly, was that less resources were being used. In the graph, we can see that we are using more and more resources that the Earth plainly doesn't have. We are using 1.8 Earth's worth of resources per year. It's only increasing. The importance of sustainability comes in that we need to be able to be reducing that number. We need to reuse and recycle so that we're only using resources that we already have. In that area, Prysmian have 4 pillars and a climate ambition. Environment and innovation are the main ones I'll focus on. Governance and social are generally in the work environment and around regulations that the EU and the UN have imposed, as was stated earlier. Within environment, it's a lot of renewable resources. It's related to supply chains. It's only using what we really get a hand of. Innovation is new materials that we can use to further sustain ourselves, I suppose, best way to put it. For example, recently, a project that I've worked on with them was recycled PET. We're trying to move away from just throwing away cable and instead using recycled material so that we're not just constantly using and using and using. In the area of energy, Prysmian tries to use renewable where possible. For example, last year, there was a 3% reduction in overall energy consumption through various uses such as solar panels and wind turbines. In my experience at Kingspan, I learned about Planet Passionate. It's their own targets that generally exceed what is scoped out to them. As you can see there is a lot of different things. There is decarbonization. There is renewable energy or just lesser consumption. There is circularity in reusing material or in feeding material back into the world rather than just taking from it constantly. And there's a lot of water recycling. There is a very specific division entirely designed around being able to recycle water. It's one of probably their greatest strengths is how much they put into the research towards these. The issue that industry finds with sustainability, though, is best summarized by these. A lot of green technology has a very large tendency to require a lot of upfront costs. Regardless of however many initiatives are put out for the average person, industry still finds solar panels, wind turbines, similar things to that, costing quite a lot. It's actually why I quite appreciate during Craig's presentation how everything was geared towards a great affordability. It's a very important factor that industry itself considers. Supply chain challenges are another issue. There have been multiple times that I have heard about during my time at Prysmian, us not having certain materials that we need for cables. And instead of consulting someone, people have just used something else lying around that was previously allowed but not checked on. There's also not too much market research that necessarily goes into some of shifting towards sustainability. Admittedly, I'm not too involved in that side of things as a lab tech at Prysmian, so I can't comment too much on it. And then the regulatory environment, I mean, as the very first speaker can attest to, there is a lot of dense legalese around such an area, navigating it is difficult, let alone complying with it. And then which areas make you more sustainable? Is it the materials you use? Is it reusing them? Is it the energy you consume? Is it the water you consume? Each area is important in its own way. So how do you say which one is the most important? These are the areas ultimately that industry struggle the most with. But not all bad. Industry offers researchers a lot. There is increased funding, let alone last year, there was, I believe, 11 billion before any expenses that Prysmian itself earned. It has money to throw around. Even recently, we got a brand new TGA machine, for example, for various studies. In the same vein, cutting edge equipment. A lot of what we have in industry tends to be quite a lot further advanced than in, say, in research environments like Teesside University, for example. As once again, hearkening to Craig, there's not a lot of money that you can just throw at what you need. You can't just randomly afford £100,000 worth of equipment where industry is fully capable. And also, industry has specific applications and practical experience. They are based so thoroughly in one area that everything they do will be based towards it. As a result of that, it presents new research avenues for everyone to look down. Not to say that that the researchers don't provide that themselves. Researchers are extremely important to industry because you have ideas that they would never even consider because you are removed from such a specific situation. Which then begs the question what industry wants and needs from research. Return on investment, mostly. Proof that what you present them is going to lead to some big value for them. Over a long period of time, definitely important. But more specifically, what people need are physical examples, such as this generator taken from Anna Predi et al. From 2017. Just something physical to show that it works and does something. And then the data surrounding it as well. Something that shows them exactly what they're going to get from either investing in you or buying from you. These are extremely important, and they're probably the biggest hurdles I actually found when it came to presenting any ideas that I have had from Ojedome over my time working with him towards industry. It's always about how it best serves them, how it would help them in the end, because a lot of the view comes down to me doing you a favor by going into this. I believe it's best summed up by this quote from Marissa Mayer: when you need to innovate in collaboration, not just collaboration between us, but collaboration between industry and universities, where we can all come together for a better future together.
More questions?
Yes.
For businesses that have never considered research or innovation as part of their business model, where do you recommend starting that conversation?
Right off the bat, I think for starting the conversation, you get down ultimately to the numbers, you get down to the finances ultimately. You need to look at where their money's coming from and what advancements could be made from the research. At Kingspan, for example, my role was based a lot in additives to a known solution formula to generate lower smoke yield for the reduction of greenhouse gases for scope 1 and 2 as part of the Paris Accords. And a lot of it comes down to the cheapest options that are the most efficient at the same time. And that baseline is where all businesses will ultimately go to. And the conversation for how industry and innovation and research comes together is simply just, here's how it can save you money or make you more money.
Question, follow up? Okay, so thank you very much for coming. Because we are pressed for time, what we decided to do now is to merge the poster session together with the break and then go straight to the panel discussion. While you're having the break, we'll just rearrange the place. So you could just have maybe walk around while we. Thank you. I hope you understood what I said.
I'm not being smug about it. I know what I do. I spent 3 years of my university time to make that. 3. No.
Oh, you're brilliant. I thought you would have.
No, I am not a public speaking person.
See?
I'm very.
University students.
Yeah, I just do it part of my job, so. I mean, this is the question, isn't it? So it's all really new. One of the things that you might be able to do, specifically because you're a woman, which is great. Yeah. And something I do. Also mentor as part of the Power Women. So in fact, you're probably a bit late for next week. School.
Yeah, so.
Women in so yeah, it's part you can start.
The feeling.
But that's
Cameras can see them.
yeah.
So the cameras can see.
Like this.
Yes, about that role model and that, yeah.
Slants.
Plants.
So this camera can see it. Maybe this front or like this.
This way. I don't understand. Are they using the table? Do they need
No,
the table?
Okay, the table. Table.
Let's take it back there.
Oh, we can use this one.
Okay, yeah.
Oh, thank you so much. Yeah, it makes, yeah. Yeah. Thank you, yeah.
Yeah, so the Power Women is a non-profit.
Don't worry.
And what they do, their primary goal is to encourage.
Yeah.
The operations. Have, again, Teesside with the North People, very white, yes, also very male dominated.
Yeah.
We still have an issue of young girls and women.
Yeah, so we have.
This works.
They don't want to.
They don't want to.
They don't want to.
So the Power of Women is about that aspirations. It's not specifically STEM and engineering.
Yeah.
I just happen to go and be that role model.
Yeah,
But for you, that would be great. And I think as well. Not all, but
Yeah,
it's
yeah.
It's still a majority.
Yeah.
So So yeah, that, and like I said, the mentorships that we do, literally, we just get sent dates through the year, and you pick the dates. If you only do one, that's fine.
Yeah.
Like your studies are, that's fine. And then there's, and like I said, that doesn't cost anything, and you can use just your time in that instance. If you want to be more involved, then there's more to do. There is actually Riley. I'll speak to Riley. I'm seeing her next week, but she's heading up the group. It's like the young person's. Like there's a society now as part of it. She's heading that up because it's for younger people. Let's be honest, one's my age or older, like we're all 30, 40 years old. And she's heading up like getting younger people involved to be those role models and mentors. To be perfectly honest, a 10-year-old is going to relate to you more than she is to me. So that again is important. So I'll have a chat with her when I see her next week to see what it is. Yeah, we can even do LinkedIn, or I do have an electronic business card. I think that's easier. Yeah, I live on LinkedIn.
Oh, yeah, that would be better. You may then know.
My work email's on my LinkedIn.
So
If I need it. Yes, that is me.
yeah, then we can. Zero. I'm not expecting this. Now. Yeah,
So I'll just tell the panel to start sitting down.
Yeah, you're not going to panel down, that's good. I saw your posters.
We had a local growth plan.
Yeah.
The local growth plan is being written.
Yeah, yeah, I've shown you before, yeah.
We have people. It's say an industry that doesn't have. Michael Kendall, but me and him talk to each other. Yeah. So it depends what you want. If you want links to industries, companies that support, Michael will be your guy. If you want support with funding, getting lab equipment,
My plan is to develop.
research, that's me.
Sort of the same.
Really standing this entire time.
Chair back here, what are you talking about?
Madam Chair.
Well, as chair. Yeah, that's the dining table.
Yeah, no,
Chairs work.
he's a teacher.
Sit in your chair. Whichever one you can.
I'll take the one that's.
Right, these are I was gonna say you asking for me. Nice.
But go-to place. So, yeah, yeah, oh yes, it's sort of the main.
Right, okay.
So I want
Okay.
to see what.
I can back.
Time is fine.
The same.
Which department are you? Yeah, thinking.
Or just it's.
Yeah, it's personal. Another building in Darlington. We need to get.
Yeah, I think this is something we need to fast.
It's like you have both theoretical and virtual. I've got electronic business in front of me, just say on the stuff. I can't imagine.
All our work about
I'm not really on LinkedIn, to be honest. I have one, but I don't do anything.
No, I don't. Sorry.
Appreciate that.
Take a photo for Alex. It was like, hey, look at what we saw.
It's just the beginning of PhD. Way to go.
What I always think.
I always think.
Sales pitch. Like, have you seen pictures of that? And the growth, just like it's got all these like the labs were maybe 90s.
Well, like dark rooms and stuff.
Like our.
Oh, okay, go on.
We literally have photos. It was on us 24/7. Like in the 90s, that was a special occasion.
Sure.
No pictures of like. I mean.
Why would you? Why would you? Why would you? Why would you want a reminder of
The entire internet's full of pictures of our lab.
True. It's very true.
When I'm 90.
Are you gonna want to remember this place when you're 90?
I'm happy to come.
Your place?
Say you're like
Had a training at you.
20 years time.
It took 2 hours. Yeah.
I'm doing this top up.
Any other time available. So, come back.
This is a steam.
Rest of the can.
Stevie up the edge.
Good. I've got a feeling for the last year that's been the case.
Yeah.
Yeah, that one was great. Waiting on 2 for the panel.
Just a sec, we're just waiting on one more.
Directly.
Right. Good afternoon, everybody. Thank you all for attending and for being patient and listening to all the wonderful talks that we've had today. We're concluding today, bar the exclusion of the little tour and demo of some of the equipment that we have, with a talk with some of our panelists. Some of these people have already been up and had a little bit of a presentation with you guys, and some of the people here also have not, but they come from a wide variety of different backgrounds and they have different responsibilities, be it in a professional environment or be it in academic, though questionably that is also professional. Get my drift. Some in industry, some not in industry. That said, please guys, I know some of you have already introduced yourselves, but if we could go from left to right, please introduce yourself and just tell us all a little bit about what you do, and then we'll begin asking a few questions and taking some questions from attendees.
Good afternoon, everyone again. It's Kehinde Omoyeni. MSc student at the Teesside University, currently studying electrical power and energy system. I'm also the chair to the Energy Society.
Good afternoon, everyone. Myself, Shadab Alam. Currently, I'm working as a postdoctoral fellow under Professor Pachikula Kumar, and my area of specialization being industrial decarbonization, CO2 capture utilization, as well as blue and green hydrogen production. So I'm a chemical engineer, by the way, and I've done my PhD on blue hydrogen production through sorption enhanced steam methane reforming.
Hey all, I'm Jinoop. I'm a senior lecturer in mechanical engineering. My background is from mechanical engineering, specializing in advanced manufacturing and materials engineering.
Hi, I'm Daniel. I'm a senior technician who works in the BIOS building. Typically cover general labs, chemistry lab, and analytical labs, supporting academics running laboratory classes and student and master's projects.
Hi, I'm Sam Knighton. I was a Teesside graduate 2024, and I'm currently a lab tech at Prysmian.
Fantastic, thank you very much. So guys, as you can see, we've assembled a panel of quite interesting individuals with various backgrounds. I just want to throw out the question to you guys at the minute. Do we have any starter questions to ask our panel regarding any issues surrounding sustainability? And if not, I'll throw out a starter question to get you guys a bit motivated.
Start.
Go for it.
For the lab technician, so how do you support sustainability?
Quite a lot of means. So sustainability is quite a large thing, right? So we meticulously go over the requirements for laboratories, make sure that we only provide as is what is needed. We make sure we substitute harmful solvents and things for less harmful, but can still produce the same outcome learning. We are currently trying to provide perhaps with some sort of the consumable-based recycling, which is typically not that available for chemistry labs because of the contamination, but through a bit of a system, we think we can provide it for all types of hard plastics, which is going to be quite good to implement when we finally can in. You know, it's just making sure that we have proper recording of chemicals, proper labeling, proper waste streams, and having all of them things just means you overly reduce, and you make sure you know what you're recycling. You make sure you know what is sitting around in the labs, because all of that contributes to the sustainability of it as well.
About equipments, what about equipments? Like how long do we keep the equipments in our lab? And then,
Yeah, so
I'm sorry, I'm asking questions.
equipment like like small or large
It
or
could be small, it could be a large one. Like, I mean, sometimes what happens is we don't use it for 2-3 years and then suddenly we want to use it and then it's already disposed.
yeah. So we keep track of all of our equipment. It's all asseted. It's all numbered. We are
Auditing or something.
Yeah, so we have a list of what's in every single lab. We have annual maintenance of it all, where everything is checked. Anything that is not working gets marked. If it's a repairable thing, we can send it in-house to the university to like engineering or electrical, see if they can solve it. If not, it'll get put in a pile, and Craig will probably take it.
I will.
Yeah.
And then we purchase it from you.
Oh, yeah, exactly. I think things, I've already fixed a bunch of their stuff and asked if they want it back.
We have larger equipment as well, which we have companies that do things like servicing and check our equipment's preventive maintenance, and they've purchased some old non-working equipment from us and then provided us with time or some extra service days for that equipment as well. So that's like a bit of a circular process. They refurb it and then they'll sell it on themselves as well. So it's not just going to landfill. And then we have stuff which we offer to researchers and things that say we keep everything the same in our labs. Anything that doesn't fit that, we'll offer it to researchers and other projects as well if they want to use it.
Thank you so much.
Any more questions? Yes, sir.
Maybe. I would like to ask a question around carbon capture. I think I'll answer that. Carbon capture, utilization and storage. Our approach. Can you say something about
Carbon capture, utilization and storage. So as you're aware, it's the need of the hour. In order to address the global warming happening, which is increasing each and every day, so we have to approach to more sustainable pathways, more greener pathways, in order to reduce this particular global warming. As you might have been knowing that in 2020 itself, the CO2 concentration level has increased around 430 ppm levels, and it is being reported that if at present we are emitting around 40 billion tons of carbon dioxide across the globe through anthropogenic, through man-made emissions, if we talk about, and if we go at the same rate, then in the next 10 years, we'll be emitting that much carbon dioxide that it will increase the CO2 concentration from 420 ppm to 450 ppm. And it is projected that if that happens, it will result in the increase of global average temperature of Earth by 1.5 to 2 degrees Celsius. It can be even more. And that ultimately will result in global catastrophic events, flooding, submergence of the coastal areas and everything. So, and lots of, obviously, loss of life and property. So in order to avoid that, there is definitely an urgent need for not just for finding alternative fuel, replacing the existing fossil fuels, but it can't happen in just like a go. So we have to think of using the existing fuels like coals and fossil fuels, but without emitting. So carbon capture and utilization. And obviously, if not utilization, then it's storage is a very vital role. Yeah, please.
get more light on our approach?
Sorry?
Digitalization of
Digitalization approach. If we can shed some light on digitalization.
I can. My digitalization is more on the manufacturing side,
Okay.
not on the carbon capture side, but
Getting the real-time data from the industries, whatever we are doing in the industries or the research work, we have to continuously monitor it and feed it to the large language model and try to optimize the process. That's what we are trying to do in the digital modeling over here. Incorporate the physics-based models, not just the thermodynamic and kinetic models, but the physics-based model. And then based on that, we try to optimize from here itself. From the
physics-based model cannot work with real time.
Yep.
We may have to use ROM or something like that for real time.
We can think of like that as well.
nowadays they combine both, like
Both the
physics-based model with the machine learning model.
First, we do something like physics with multi-physics based like our, so, and then we go to the real time.
So you generate data from the multi-physics softwares, simulation modules, and then use it for AI, then use it for the predictions, which can be.
It's a very good question, yeah, because that's future.
I just wanted to go back to, sorry, the first question, jumping around, about kind of your lab sustainability efforts. Do you think students recognise what you're doing, and do you think there's something there to educate and inspire students?
Oh, yeah, I'll get Sam to comment in a minute, but like, I've worked at Teesside University for 13 years now, and I was a student. But I've worked like every year. I work in the labs with students as well, and to be honest, half the people don't have a clue and don't really care and just throw stuff away without question. But you get a lot that will go in, "What, you just throw this away after one use?" And you have to give that awkward responses like, "Yeah, it's one use, just throw it away." So that's kind of why we're kind of pushing a bit more now towards, you know, we're going to introduce it to lab inductions. We're going to make it part of the lab where there's, you know, separate containers. We're going to explain a little bit more about the process, and it boils down to us as well, because we, as technicians, just in preparing labs, and I work in an analytical lab, so I use a lot of that to prepare standards and to prepare samples. So us being part of that as well will also help the students get all this recyclable plastics together, and hopefully it will work. It's just finding a useful system, because, you know, getting 100 people in a lab to do something effectively and well and not mess it up and not put them in the wrong bin, it's quite a challenge to find something that's going to work like that. So we'll probably do a few pilot studies and like a few pilot modules and see how it goes. But yeah.
Give you more work.
Oh yeah, that's also the problem. I got to try and reduce the amount of work it is for the technicians. Or we don't want to be sitting there just sifting through bins of pipette tips and stuff. Just to, you know. But yeah, how did you find?
Short answer: no. The technicians don't get recognised enough.
Oh, thank you.
I would say the complex answer ultimately is that it changes as you grow through uni. You know, in year one, I can say with great certainty, completely unrecognized. Literally, the focus was on, this is my lecturer, this is the lab, do the thing. But as you progress through, and eventually when you take on your own project, you actually do tend to realize very quickly into it both how important sustainability efforts are, but also what the lab techs have ultimately been doing for you during that time. There's a load of different things that I can think of where it was like, this would already be done for me. I wish I wasn't doing this. I remember, for example, making up a 1 liter standard phosphate buffer. That is like normally these guys would be the ones doing it. People would just go, yep, that's there, and it would go unnoticed. It's like, lab techs really, you guys are so important to this educational environment, and you really don't get enough notice.
I'm going to slightly develop a little bit on what Dan just said there regarding practices in industry. Obviously, right now, we're all at this lovely conference learning about all various areas of sustainability and energy harvesting. And hopefully, we're all going to take that information and go away with it and do great things with it. Now, I'm curious about how you guys are going to take this information and your sustainable practices, disseminate it through the people that you work with. How do you potentially see this opportunity to disseminate what you've learned here going forward for future projects and for future practices?
To start off, like, I think the one that you are doing, the ones converting the lab waste, converting the plastic waste that is generated in the lab to actual product is really, I'll say, it's a motivation for everyone. Like, it leads to reducing the waste significantly. And at the same time, as we discussed, I think we need to have more approaches towards sustainability in engineering labs. I don't think we have these sort of approaches in the engineering lab at the moment, where we don't consider this in inductions. So one of the labs where I am working on, I would like the technicians and as an academic also give proper induction to the students on how to responsibly use materials and equipments. There are standard operating procedures for the equipment. So now we are discussing about consumables. So, like, for the condition that the equipment gets failed because of not following the standard operating procedure, equipment is gone. We're losing their equipment. So I think everything starts off with the induction. even if the academic is using or the student is using, we should be able to provide proper induction to them and give them the standard operating procedures, what is required to be done. Don't deviate from the standard practices. So these sort of guidance in the lab will make a lot of difference, I feel, but it's difficult to implement. But I think it's a culture that needs to be developed. And as we move forward, it will be developed.
Anyone else got anything to add to that? For example, it'd be quite interesting to hear, we've obviously got an academic perspective right here, and I imagine yours is the same way. You want to improve the amount of sustainability and improve the amount of sustainable practices. Whereas we have two people here who are a level student and we're an undergrad student. How do you feel when you first started at university or started in a lab or in an engineer's workshop? How do you feel you were taught about sustainable practices then versus how you are now?
Well, let me give what I used to think when I was doing my PhD. So in between doing my PhD, I used to started thinking, since my topic is to reduce the global warming, blue hydrogen production. So I was wondering, means the amount of paper that I'm using for printing, the electricity that I'm consuming, if I stop doing that research, this particular research, I'll try to save more plants, which will reduce the global warming. So, so in that regard, I can say that everyone should be try to do in his own think, means whatever work you're doing. So whether it may be sustainable or for a greener pathway for the future, whatever the work that you're doing. So think morally, how is it going to be really helping, and work on that aspect, how by every individual can reduce the emissions in that regard.
Just wanted to answer that, like as a student, when I started, I didn't have any idea of this. So once we become the person who's going to be responsible towards that, for example, now I'm running a project, I'm responsible for the budget of it. I'm responsible for the student who is doing that project. I'm responsible for the outcomes of the project. Now I can understand how important it is to sustainably use the materials, sustainably use the equipment. But as a student, maybe I was not taught, should have already realized by myself, but it didn't happen. So that's why I said the culture needs to be developed. It should be embedded in the education itself. And if that is embedded in the education, it will come on and everyone will start doing their way of doing this.
When it comes to being taught about sustainability, I would say a lot of it, even when it begins first year, you get taught it without realizing you're being taught the sustainable practices. A lot of it is just do this thing and you do it and you don't realize why that is then sustainable in itself, compared to like this entire conversation, which is this is why it's sustainable. You do the thing and you don't realize that at that time this is for a sustainable purpose. This is so we can continually use something rather than just do it.
That's what I was going to say. Basically, as technicians, when we're setting up labs and we're setting up procedures and stuff, we are kind of considering all this sustainability, but we're not really telling them this is why. You know, we have the reason why we hammer like labeling of specific samples. Obviously, one of it's to do with safety, but another part is it so it can go in the correct hazardous waste stream. So you know, you're making sure things are going in the right way, so they're not just getting generally disposed of. You know, why do you close the sash of a fume cupboard? Yet some of it is safety, but also you're using a lot more energy to pull air through it. You don't necessarily tell that to every single student when you're telling them, but you're there constantly monitoring all these different things throughout a lab.
Let me add something here. This could be the reason. The reason could be because most of us are approaching teaching in a traditional way, like the time when sustainability was not important. Like my time, sustainability was not something, because that time pollution had just started. We never thought about this, future resources. We just had to go with that. We never thought about the next generation.
Yeah, chemistry is a lot of things that have always been done the same way. Experiments from the 1900s, which we just do now, but they're using chloroform and things. It's like, well, no, we're not going to use that anymore. We're going to use this. But, you know, you get requested to use that. You have to have this conversation where, you know, we can use something else. We can find a substitute that's nowhere near as bad.
At A level, I have done dissection with chloroform in the white rat I was nailing it, and chloroform was used in excess.
Yeah.
Nobody said anything.
Yeah, it comes up a lot.
I'm inclined.
One question, sorry. Fine. For the technician. What is the current sustainability standard? Is it bronze, gold, or silver?
We currently aren't under any sort of framework that would award such things like that, but it has been something that, as a technician team, we've been trying to push through our management to join the LEAF program, because I think there's quite a lot of labs that would benefit from it. I've done quite a lot of looking into LEAF and the requirements for each of the things. Now, I'm almost certain that we'll have bronze straight away. Like a lot of the things on there we already do, no problem. I don't think it would take very much to get silver and gold in a lot of our labs, especially the science labs anyway. That's only because I don't work. Sorry, that sounded awful. It's only because I don't work and I'm not familiar with them other labs, but a lot of the gold standard ones are they look quite difficult to get. Like they would require quite a big change in a lot of the practices that we do. But again, I don't know the full framework. I haven't gone through that, and I don't know how much that would be to change. So I'm kind of just waiting really for upper management to say yes. Hopefully they say yes, and then we can sort of round and get assessments and gradings for each of our labs.
Dadashi, I see you've got your hand up on Teams online. You kindly unmute yourself and ask your question if you've got one.
Yeah, thank you very much for organizing the.
Stay with us,
the
Dadashi, we
meeting.
can't hear you.
Okay. Let me
Muted, but there's
see.
no volume.
Just a moment.
Sorry, Dadashi, bear with us, we can't hear you.
Do you hear me now?
Yes.
Good. Thank you for organizing the meeting, Ojedomo, Craig, and all the lecturers and the audience, actually. I have one personal experience because I was to Japan for 10 years, right? I work with those people's days and sometimes nights. They, in the past generation, in their wooden ship industry, the carpenters did not tell the trainees how to make the ships, right? They had to look at them the way that they used to make the ships and learn just by seeing that project. I tried to practice that one here in the UK when I joined Teesside University early 2022, but I soon after that realized that it doesn't work. I should tell the students. My point is really practical and can be very useful for the especially students in the laboratory. In biotechnology, microbiology, these kind of experimental laboratories, we use a lot of latex gloves, right? And I've seen some of the students up to 10 pairs of gloves they discarded in one single day. And this was the point, but with, compared with the Japanese style, it doesn't work yet. I should tell them. Now I tell them in the first day when they get in the lab. And now when they weigh some chemicals, if it's not contaminated with microorganisms, if it's not really contaminated with some, it is not broken or something like this, I ask them simply, please wash it under the tap water and bring it back and put somewhere to dry, air dry, just simply. And I do it by myself. It happens to me to use a single pair of latex glove for a week. So just to say thank you to you all and share my own experience with you. I hope that it would be repetitive, but forgive me if it's repetitive, might be useful for some people. Thank you very much.
Thank you, Tadashi, that's great. My last question for myself, oh, sorry, we've got someone from here.
A question / experience. So when I studied masters, now I am doing my PhD. So when I studied masters, we all the students have mandatory sustainability class, but we discuss about SDGs and everything, but not in a lab scale level that we can practice. So we talk about maybe India, Singapore, all the countries level. So when you talk about sustainability labs, so it will be helpful for the students to think in a small scale level, such as especially for engineering students in the lab scale, then they can think about like country level, start from the lab. So my question is to Dr. Jinu, because he's the only one who's the head of that team. So like, how can we start like that rather than like a big scale, like small scale, the engineering students, especially bachelors and masters students?
I think, thanks for the question. I think it's something that we need to embed into the curriculum. Like, we need to have small sustainability related. I know the module that you're talking about is a largest MSc module on sustainability. It covers all the different branches like mechanical, electrical, all the engineering branches are there. But because of the challenges, the same challenge that because the number of students are more, that's why we're not able to add a lab session to it, and we couldn't add a practical session to it. But I think as a more and the trend that is going on in the engineering at the moment, we are trying to have more lab based teaching and less theoretical teaching nowadays. So that's how the trend is moving forward. So I think we will introduce more of experimental hands-on trainings in the sustainability module. That's a way to go, so that students can see the small scale systems and then they can think about the large scale systems at later stage.
I think I've got a final question for you guys today. We've obviously talked an awful lot about the importance of introducing sustainability into labs and into lectures and everything like that, making people aware of these practices. I've got a question here now. It's a bit of a two-part question, so please feel free to dot around to try and answer this question. How do we prevent over-informing students? Because if they try and learn a protocol for the first time and understand the sustainability practice at the same time, and again, this is coming from a student's perspective, we also need to translate this to real world. How do we also promote sustainability practices to the regular person, not over encumbering them with information? That balance between the two. What sort of solutions do you potentially envision or can see that might be useful for us? Bit of a difficult question. So if you just want to take a bite out of one part of that, that's perfectly cool.
Over-informing is going to be the biggest issue ultimately, where everyone is more online now than they ever have been. Information overload is not just a concept, it's a fact. You know, and we see the real world effects of it in even the younger generations now, where you can say whatever you want at them and they'll go, yeah, I know. And they just, there's a lack of care towards it, I suppose. Biggest issue, I think, only comes down to making them realize why it's important, because a lot of younger generations nowadays do seem to just shrug off everything like it doesn't matter.
Yeah, you can't over-inform students that's already quite overwhelmed about being in a class, reading chemicals, reading hazards, think about safety. Then you go, oh, by the way, put it in the third bin from the right and make sure only that plastic goes in there and the red one goes in there. It's not going to happen. You need to make it as simple as possible. You need to include it into a typical like procedure. It needs to be, you know, it just needs to be as simple as possible and sort of second nature to them working in the lab. But obviously, that's like, you can, if you know how to do that, let me know, because we're trying to think of how to do that for the next year. But yeah, we'll trial some things, containers, color coding, maybe like an actual class, you know, where you do basic lab skills, where you learn how to do various basic things, maybe include it in that. Not sure about telling them that putting it in the wrong bin's bad in the world. I'm not sure that's going to make them do it anymore, because they probably know it already. I mean, if you got to uni without knowing that putting plastic in the ground is bad, then, you know, I don't know. So, yeah.
What's that expression about, Craig?
I may propose, right?
Sorry, go on.
Yeah, I may propose. I mean, if the introduction of outdoor events like trips, the students, they also go to the field and see, to improve, it will help in how we see sustainability.
Tangibility. Right.
All right. Yeah. So I think I was just thinking about when you threw that question. Why are we looking at teaching or creating awareness on sustainability as something that has to be taught in the classroom, or it's when you become a student? What about people that are not students or they're not in the universities? I think, or even at home, you know, how. So I think we should just start looking beyond traditional way of knowledge exchange or teaching, promoting sustainability. For instance, I think, what do youths, young people engage? I mean, before they even get to the university, if there's an opportunity to let them know this is how things should be before you get into real science, and you don't have to be a scientist to practice sustainability. So about Dan, for instance, you're making TikTok video. You know, you could have got it more wrong.
Imagine it with a song in the background, be like, put it to the right.
More so with down instead of wrong.
You've seen this?
No,
Just pass it around, you see, I think,
Yeah.
so much,
Something like that. I mean,
almost like that was planned, it really wasn't.
yes, and
it's part of the project, it's part of the curriculum.
That is cool, actually. This is for this generation.
You on TikTok?
I think
So,
what-
you get a lot of views.
I understand that that's a good outreach. It wouldn't be me.
Yeah, the field trip,
Chloe.
Please TikTok.
learning, isn't it? Like, yeah.
Lucy and Meg, come on, they've got to be.
I think
There's a website where you can see a lot.
field trip with, we need to make them realize, as you said, the current generation, what's want and what is need.
Yeah.
The difference between want and the difference that is between want and need. If they know the difference between want and need, I think then field trip is something which they can see, and then there is, the future world is sustainable.
That tangibility, the idea of actually seeing what the solution is, can be way better than you're seeing it on.
Yeah, and to see the difference, what is want and what is need.
Well, yeah, so your hand was up.
Or in response to kind of what I've seen in labs and your question, how do we put that alongside? I kind of have two options for approach. I don't know if you'd agree, Dan. The first is we don't teach them about sustainability. What I mean by that is, in order to find sustainable alternatives to things, you have to understand the basics of what you're doing. I think that happens a lot in our labs. Students don't understand the basics. They can't innovate, they can't troubleshoot, they can't think of better alternatives. The first thing is you don't necessarily focus on sustainability, but by teaching them real critical analysis and critical thinking of everything that they're doing and getting them to completely understand something, they then can kind of develop sustainable practices and question, well, why do we use this? Why do we do it this way? And they'll learn naturally. And I guess the second one is, you don't try and kind of stack them. You have them starting off with real basics. They're not jumping straight into a method, because I think that's part of the issue sometimes, is you want them to do a simple method, but they don't have the understanding of the basic techniques to be able to perform the method. And especially with kind of undergraduate students, they're so focused on getting an outcome or a result. They just want the right answer. They forget about how important the process is, and actually the process usually is the most important part, and that's where we want to get the learning. They're not necessarily learning by just getting the answer, but that's the bit that they just want the answer. Is that right? Is that right? Is that what I'm supposed to get? It's like, well, the process was more important. I think they're the two kind of things that I would consider how we teach sustainability.
Sorry, Z.
So I just to request what it's, we know about sustainability. Sustainability. Economy was very conscious. If you are told me, definitely do not turn on your heater because it's summer. It will. So you economy makes you sustainable. As you look at sustainable practices in the home itself. So they know about that. In other client universities, you have like integrated team, so how different colleges. It's not like everyone's agreed when you understand about exactly, definitely. But it's just the language it is coached in. Most are not. So when you use sustainability, it's like a very big scientific something. Just bringing it down to their levels, you know. And then one other thing is incentives. if like you have some countries that
With glass bottles and corner shops, you could say.
just if technicians say, okay, you get a kind of every 1,000
Premium branded stuff.
sign up for it, I believe so. Because nowadays it past this
Incentivizing.
That's true.
That's just my
We're just going to go with this gentleman at the back, and I'm afraid that'll be concluding our panel. I've unfortunately gone a bit over time. We've been a great discussion. Thank you very much, guys, for everyone participating. So we'll just hear this last question and.
So I have another question regarding the life cycle assessment. Any of you use a life cycle assessment tool? Your material production or your process, how you are sustainable. So we need to have a tools to define the sustainability, isn't it? So any of you are using the life cycle assessment tool?
Used the projects, but
Really great. So in the lab as well. But any assessment like that to see how sustainable you are practicing?
Yeah, so that's why I've pushed for these assessments to come through.
I think the university should support you because I've been to University College of London. All the lab are called practice. They are recycling everything.
Yeah, we've been pushing it all summer, and I've brought it up in like PDRs and things like that. And we recently had a big technician survey amongst all of us, and I think a lot of us put in for things like extra training in these sorts of areas as well. So we're prodding. We're just waiting to receive the information. Yeah.
Great stuff, guys. Well, anyway, that's going to conclude our panel discussion. Thank you all very, very much for all of your questions and for technically participating at the same time. One last time, one round of applause for our panel. Now we're having the opportunity to go for a little bit of a tour of this facility. If you've not already had a chance to look and see some of the equipment that Dr. Dolman went through are going to be using. While you're at it, please take the time to read and have a look at some of these fantastic posters that have been produced for this event. Some of them are very, well, all of them, I take that back, all of them are very fascinating and interesting, so please do have a read. Thank you very much for coming along today, and I believe we have one last little farewell from yourself. Is it Dr. Dolman at the end of this session?
Yes, but it's essentially just to thank everyone for coming really. Yeah, I've learned a lot as well from everyone. And the whole idea is just to get the idea of sustainability amongst ourselves, across our different professions and fields and all. So thank you for the discussion and the support, really. So yeah, hopefully in the future we're able to do more of this event, and then of course the university can open up opportunities for us to really continue to sustainability measures. Thank you so much.
Thank you very much, everybody. So if anyone's interested into it, please go outside and join with Ellis. He'll show you around. If not,
You have idea.
So
By the way, Chloe, it's my resting angry when it's not common at all undergrad. So
I've been hanging on for Haldane for quite a while now. So if you do find out anything, I really
To my
want.
line manager, and I've taken his management. I don't know where it goes after that.
Yeah, I keep mentioning it to people and I keep making noise about it.
With it,
Hey.
and you don't know how much you have to pay until they come in.
No, this is really interesting, really cheeky of them, because I've been looking for this.
They're gonna have to kind of take them away from the team already to be champion
It's going to take
in the school / university. We have presidents that aren't even in the school, so that probably makes it confusing. Payroll and HR and what their job title is.
We're going to need it because there are programs that are now saying
it's on the size.
Surely it helps accreditation for the authors, for different labs and things like that.
when you're here, I'm very much willing to get stuck in and help as much as.
Yeah, we've got a few of us, so it's not just me.
I know, you're the one who mentioned it. Now you're the one that I've come to bother.
Yeah, Alexa, who was here earlier as well. Chloe works mainly in the many analysts. So yeah, we're all kind of. Oh yeah, well, this is it, you know, we're so involved in all of it.
Favourite thing is telling people to put the hash down at the end of the day.
Yes, I'm gonna get. I don't like signs everywhere. I'm thinking I'm gonna put. Yeah.
Yeah, I know.
Yeah.
But anyway, yeah, as I say, I'm
Pushing
around.
for it, we'll try.
No, I know. It's overnight.
I just say I love that the very first question was Dan, and I jokingly said,
And the second one, and maybe the fourth one and the seventh one.
We're all going towards people that they haven't heard talk yet.
did well. Did very well, sir. There was a moment where you're like, actually, you know what? I've got something to say right now.
Well, I could have carried on. I could have the surface really.
I kind of wanted to pick you back up.
Certificate I have.
I already took my reference.
No, just this one. This one.
No, it's fine. Which one?
Talk.
For him?
I've done this already when you were presenting.
Let me see.
Golden chips.
Oh, come.
I don't know why I did it. This is golden chips.
You're not serious. Can you imagine? See, you set me up. I would say I'm pleased to announce that. It's still nervous. That's why.
Everybody should come for the
Yeah, come in. He's quite good at taking pictures. He has a very sharp photographic.
Here's going to put the door.
That's all.
Let's go for the tour. Oh, gee. All right. Are you not going to take a picture? Yeah. Are you not going to take it? Oh, attend it. Come on, man. Came from somewhere, definitely. How would they know that? Thank you. I suck at taking pictures of, unfortunately.
You're trying. That's what matters, right?
Still be outside. Most people